there's one more type of audit that is conducted, and that are automatic inspections. And this is a point where I would like to talk a bit more about. So here you see an old image from Lloyd's register. You see that this is obviously the cargo hold of a bulk carrier, and there is this vehicle that is using a sort of a hydraulic crane in order to inspect the area up here. I honestly have difficulties to see whether this is whether there's a person or not, because it's a very old image. But in any case, you need to have a person that is operating that vehicle. And when we talk about automated inspections, when we talk about automated inspections, they basically go a bit beyond what the remote inspections have been doing. So they try to work fully independent, so without any human interventions. And you can see here one sort of climbing robot that is placed on the outer hull. And that was an European Union project. And the basic idea is that these autonomous units, whatever they are, use non-destructive testing devices, collect data, and are also automatically processing them with algorithms. And such technology will then allow the surveyor to evaluate the structural condition at a safe and stationary location. Especially about the second point here is where that these units are already analyzing and evaluating the condition of the defects or particularities that they find. That means that you obviously also need to be able to connect the images, whatever images those are, or measurements with an algorithm that is then evaluating that in the background. And just as an example, when I was on my recent voyages on a ship, there was a PhD student for biology in the same office with me. And he has been taking these small water samples and was taking a photograph. And then he had a computer that was using AI models in order to analyze how many species and what species he actually had in these small water samples. And these robots or autonomous units, they are supposed to work in the same way. And here you see a compilation of Lin and Dong and Schliveros about some of the common defects that should be detected or are subject to the inspection. We have general corrosion, we have pitting corrosion, we have weld metal corrosion, grooving corrosion, we have cracks. And this is actually also the first thing where we might raise some questions, because is this really a crack or is it just cracked paint? And that is, of course, then the difficulty is also with the machine learning algorithms or the artificial intelligence to train that in a way so that these features can be detected. Then we have deformations here, obviously some dents, coating breakdown, and the consequences of some biofouling. And Lin and Dong, they also provided some challenges and divided them in 3 types when it comes to these automatic inspections. So the first challenge is the collection of data. So it's a challenge for autonomous systems to collect the comprehensive data without missing a part of the hull structure. And if you go back and look at this robot and how it moves, and if you look at some of the elements here in the hull, especially the deformation that we have here at F, it might also lead to the fact that the robot cannot proceed, or due to the local inclination, might not be able to record the designated area, which are all potential problems in the data collection. Then the second point is the identification. Is the algorithm struggling to promptly identify defects correctly from the large quantity of data without missing facial defects or maybe misinterpreting defects? The latter is maybe not that bad, rather being safe than sorry. But on the other hand, if that occurs too often, that would also increase the workload afterwards. And then, of course, significant calculation power is needed in order to have real-time analysis available. And for those of you that have already been using some machine learning or AI-based analysis, you might know that some of them actually take a while. And in this particular case, if you think about this autonomous unit, it is not only recording at one instance data, but it's collecting data all the time. So the amount of data is increasing all the time, and which might also reduce the computational processing time. Then third is the assessment. So it's challenging to conduct structural condition assessment using the defect information for decision making. So because also if you look at the area that this robot or this unit is surveying at the time, so it is basically just a small snapshot. And if there is sort of a small dent detected or a small crack, so is it actually critical for the structure or not? So this is also something that might then be need to be put into perspective when all data are recorded of an entire area. But if this is feasible from the amount of data and the processing, remains to be investigated. Or maybe a completely different approach might be needed for that.